Hello everyone and welcome to a new video. Today we're going to take a look at an exercise from the mathematics admission test of the University of Oxford from 2021. So this test is designed to be approachable for all students. That means if you went to school, you should be able to pass this test without taking further classes in mathematics. So let's find out if we were able to pass this test. So the question that we have to answer here is, what is the sum of sine square of 1 degree plus sine square of 2 degrees plus and so on till sine square of 90 degrees. As this exercise is taken from the multiple choice part of this test, we have 5 answer options: A, B, C, D and E. So the nice thing about this exercise is that it might seem a bit complicated. So it seems like you have to know a lot about the sine function. But actually, this exercise is not that complicated. It's solvable quite easily with a simple trick. So, and especially for this exercise to solve it, you don't have to know any concrete values of the sine function, like sine of 3 degrees or something. But what is always useful to know is if you know at least like approximately how the graph of the sine function looks like. And this is what I'm going to start doing right now. I'm going to draw a little sketch of the sine function, and really only a sketch, as you would be only able to do in the test. So the sine function is a periodic function that goes up and down in the interval between -1 till 1. So yeah, I try to make the sketch as beautiful as I can, which will not be that beautiful. So, but in red maybe. So the sinus function looks almost like this. So it goes up and down, is periodic. And so yeah, I hope you recognize it if you already know the sine function. So you can see, well, for example, sine of 0 is the same, equals sine of 180 degrees, both are 0. 100 degrees further at 360 degrees, sine would have another 0. And also to the left and to the right, you could continue this graph indefinitely, even though you would have to think about 450 degrees, for example, as 90 degrees. But yeah, that we can do to make a sketch of the sine function. And also, as you can see, you can see in the sketch at least a few values of the sine function. So for example, you see that at 90 degrees, the sine function has a maximum at 1, and at 270 degrees it has a minimum at -1. So yeah, a few values you can see from there. And so yeah, I mean, this this sketch in general, it's not a nice sketch, okay? But we are anyway actually only interested in this interval here, the interval between 0 and 90 degrees. And here we cannot really read like any value of the sine function. For example, this, like still we cannot, give the value of the sine function. But we can see at least that sine of 90 degrees, well, because there's a maximum, equals 1. So this means that we have at least one term in our sum, sine square of 90 degrees, because as sine of 90 degrees is 1, sine square of 90 degrees also equals 1. Okay, yeah, but for the other terms, well, yeah, we cannot really use this sketch directly, so there we have to think about how do we get these values anyway. And there we use a trick now. So what we will do to also get the other values, we will include the cosine function. And this is nothing that you would, well, immediately think of, because, well, the exercise is something that has to do only with the sine function. So why would you make it even more difficult by also including the cosine function? Well, yeah, but if you do know approximately how the graph of the sine function looks like, you also know how the cosine function looks like. Because as the sine function, the cosine function is a periodic function that also goes up and down in the interval of -1 till 1, and actually do like exactly like the sine function, only that it is shifted a little bit. So the cosine function has its zeros everywhere there where the sine function has its maxima and minimas. So this is the cosine function. And yeah, the cosine function has its maxima and minimas everywhere where the sine function has its zeros. So, and that the cosine function is actually the same as the sine function, only shifted, and to be concrete, shifted by 90 degrees, is something that we can also express mathematically. Well, because you see here this value, sine of, well, whatever this value is, x, equals cosine of exactly this value x, only if I shift x by 90 degrees to the left. So maybe it's not it's not that nice here in the sketch, but I hope you see what I try to explain. And to express this mathematically, we can say in general sine of x degrees always equals cosine of x degrees minus 90 degrees. Okay, and here I can write either x degrees minus 90 degrees, or I can also write cosine of 90 degrees minus x degrees. Because as you can see also here in the sketch, well, maybe I add a little bit more of the cosine function. The cosine function is symmetric to this axis here, right? And this symmetry means that in general, cosine of any x degrees is always the same as cosine of minus x degrees. Okay, and now we actually already got this. Because what we can do now, if we know about this, and what we now know is, well, only this thing here, what we could simply see in the sketch. If we now look, for example, at this term here in our sum, sine square of 89 degrees, we do know now that sine square of 89 degrees equals cosine square of 1 degree. And what we can do now is we can sum up exactly this term with the first term in our sum, sine square of 1 degree, and use like the one formula that I think everyone always remembers, even if you're not that familiar with cosine or sinus, which is sine square of x degrees plus cosine square of x degrees always equals 1 for any x. So yeah, this is a formula that you can, if you forget it, you can also derive it geometrically. I did this on Instagram if you would like to check this out, but here I'm only going to use it. And this actually is the trick that you use here in this exercise. Because now these two terms here, sine square of 89 degrees plus sine square of 1 degrees together equals 1. So, and for all the other terms in the sum, we can use exactly the same formula. So, for example, this term here, sine square of 88 degrees equals cosine square of 2 degrees. So this plus sine square of 2 degrees equals together 1. And all in all, we can use this trick 44 times. So this means that our sum is the same as 44 times 1 plus, and well, only one term is left, which is sine square of 45 degrees. And we don't forget about the sine square of 90 degrees, which was 1. So we have 44 times 1 plus 1 is 45 plus sine square of 45 degrees. And now to give an answer to this question, we only have to find out what sine square of 45 degrees is. We have 3 possibilities. So the first possibility is, if you do take a look back at the sketch, then you see that 45 degrees must be somewhere, well, somewhere here. But you can say for sure that sine of 45 degrees is something which is for sure more than 0 and less than 1. So, and then you can take a look at the 5 answer questions, A, B, C, D, E, and see that the only answer that would fit then would be D. So that this sum equals 45 1/2. So, well, the second possibility is you coincidentally know the value of sine of 45 degrees. It is actually 1 over the square root of 2. So this as a square equals exactly 45 1/2. So it also would lead to answer option D. So, but the third possibility to, derive the value of sine of 45 degrees is probably the nicest one, because you can also get it in a geometrical way. Because sine of 45 degrees is the same as if I have a triangle with 2 side lengths of 1 and a right angle here. Then this angle here would be 45 degrees. And then the sine of 45 degrees is equal to the side length of, well, of this side here, which is 1, divided by the side length of this side here, which is, by Pythagoras, the square root of 2. So here you would need a little bit, trigonometry. So here you would have to, know a bit more about sine and cosine and, well, all the trigonometric functions in general. But yeah, anyway, I think you have like a good chance to solve this exercise with less knowledge. And well, yeah, I hope you enjoyed it. I hope you enjoyed the whole video. Let me know in the comments if you were able to follow, if you would have been able to solve this exercise. And if you have any questions left, you can also let me know. And I see you in the next video. Bye.